I'm Maeve McCormick from Group 3 in the Kongersluslag Field School. And today we were working on a project with discharge and sediment transport in the Kongersluslag fjord and the Watson River. So as part of that, we interviewed Andreas Mikkelson about his research on the fjord.
My name is Andreas Mikkelson, and I'm working as a PhD student at the University of Copenhagen in Denmark. And my project is about the Watson River.
This question is, how did you get interested in this kind of research?
I started out studying geography, which is very wide subject, or broad, you can say. But I was pretty interested in kind of the nature and how nature works. So it was not very specific in the start, and then I became a bit more interested in climate, soil, hydrology, and stuff like that. So it's along the way, but it was not that I knew from the start that this was what I wanted to do.
So what kind of experiments are you doing here in Greenland?
Well, basically I kind of do the same you did today, but in a bit more advanced version. I wouldn't call my stuff experiments. I more say I measure stuff here. So I measure the discharge and the sediments transport, and also some of the input, like the snow precipitation, to this catchment. And I use those data then to calculate the runoff on basis of meteorological data. That's the same kind of as modeling the runoff. And then also I look into kind of what's the rate, or how fast does a glacial river like this form deltas, and what's kind of how big are the fluxes, and how can, if possible at all, can they be compared to previous glacial damage, which that glacier did not, like, for instance.
Okay, so what is your main goal with these measurements?
There is more than one goal. It's a number of smaller goals, but one of them is to so we, the whole society, can be better in understanding how does a hydrological system like this big part of the ice work, and if something melts on the ice sheet, how fast does it drain, and does all the water drain out, to get a better process understanding, and therefore be able to calculate and model runoff better. And then there's kind of the thing that relates to how landscapes form, and that's again to get a way better understanding, because it's very rare to measure like geomorphological fluxes in this scale. So that's kind of the goal.
So how do you apply the information that you gain from these meashments?
How do I apply them? Well, that's I should answer that question. It could take a long time, but some of it is to let's say break it down and take one step at a time. So I apply the information I get to be better at the process understanding. And I mean, even though there's a lot of science going on, we don't know everything about how this glacier, this system like this works and drains. So one thing is to find out some small pieces in the puzzle, sort of to say, and then what a scientist do is then we publish in scientific papers, and if it gets published there, it means that it's been accepted by some reviewers that kind of say, well, it's okay, and